Hello, this is the presentation of Ship Engine Room Simulator developed by GDS Engineering R&D Inc. This is Dr. İsmail speaking. This part of the presentation is for the big view approach, which is out of the unique features of the SERS. The Ship Engine Room Simulator has a trademark and abbreviated as Ship Engine Room Simulator. In this presentation, we're going to be talking about big view approach and 3D preparation works. We did not integrate the 3D fully yet, but we have some preparations towards it. And also, there's a difference in our big view approach than many other simulations, engine room simulators. I will be going through all of those in this presentation. Well, this slide already you have seen in the previous presentations, so I'm gonna go directly to the where we talk about the unique features. In our previous presentation, we talked about summary of unique features of SERS. Please refer to that YouTube video. And now we're gonna be only talking about difference in big view approach and 3DWorks that we are working. This is the complete list of all of the slides. I won't be coming back to this list, but it can be referred as the complete list and printed out maybe. First thing to say is the detailed layout must be maintained. Either you are doing like 3DWorks or you are distributing the views into the panels, the detailed layout should be maintained. There are more than 10,000 parameters to be able to completely model a ship's engine room. Too many parameters, too many components, and so on. So how we understand the condition of these systems is the variables. So variables and detailed layouts are very, very important. On the right lower corner, you see that there is a mimic panel. We had this simulator 20 years ago, and these mimic panels really, even though they look complex in this view, they were not enough to completely detail the software version of the simulator. So students, they like it at the beginning. Yeah, that looks awesome and awesome to demonstrate to others visiting the laboratory and so on. But eventually what we started practicing is the students could not find some of the valves, some of the parameters here. So they found them in this software. So they had to move to software, and one guy doing everything in the software, everything works. And unfortunately, like if you assign, let's say 5-6 students into this engine room simulator for team training, you see like one guy figuring out like he can do everything in the software and he does everything in the software, and you cannot understand who is doing what. So that was the problem. And what we did as a solution is, one rule is that the distributing to layouts with mimicking, with using large touch screen panels, we don't want to lose the details. So whatever the screen shows in the software, it is gonna be showing on those panels. This is the one rule. Details must be maintained. Second rule is the students should only see the designated GUI panels. So if the student can only see compressed air system here, he must do that here. So you can assign one student as a chief engineer, and the other one is second engineer, and the other one's third and fourth engineers and electrical technician, depending on the how big your simulator is, the area is. You can add like engineering cadet as well. But basically, for each panel, you can assign students. So then the teamwork becomes realistic. One person is waiting on another doing some action. In this case, on the right, you see the student has lined up the emergency generator, then lined up the circuit breakers. So basically, all features with electricity, now lining up the diesel generator. Meanwhile, the students on the very left he did the role of third engineer. He is lining up the compressed air system. First, he lined up the emergency compressed air system or auxiliary compressed air system. So now he's filling the tank so that the diesel generator by the other student can be lined up. So they depend on each other, and the chief engineer here does not do anything, basically just coordinates the effort. So when the detailed layout maintained, when you distribute the item to different panels, large screen touch panels like 65 inches for example, you can achieve really good teamwork. And what do we mean really detailed layout must be maintained? What does it mean? Well, I said briefly more than 10,000 parameters exist in engine room simulator. You see like engine room here, freshwater system only one GUI panel out of many. We have total of 56 GUI panels right now. You know, that is increasing every month almost. The last one that we added was ballast water treatment system. Now, so this is only one, and this has already has a lot of complexity. So if you want to, like, let's say you want to have the continuity with 4 screens, then you won't be able to fit everything there. So what we are doing is we are grouping the related GUI panels into one screen, as we have shown in the previous ones here. These are all grouped by by panels, and the student on the right has all access to all of the electrical engineering panels. So and the continuity is still maintained, because like if the compressed air is not prepared here on the other one, and you don't have air, you cannot start the diesel generator here. So that is what we mean by the continuity in our perspective. So the details should be maintained. The valve details, this is butterfly valve. Well, where this is globe valve. You know, you can see from this picture the valve types, and also you see the adjustments for adjustable valves, and also you see numbers like how many, what's the degree of temperature fresh water going into the main engine, where it is entering from and where it is leaving, and how many degrees. You can adjust the PID parameters and so on. So this is the same version that we use in the desktop. So the desktop version and the full mission distributed panels are the same version. So student practices those, and when he goes to the distributed system, he sees the same things, and he is familiar with the type of the ship, so he doesn't need to figure things out again. And one of the details is the these controllers, local controls. Local controls must be there. Okay, there's a YouTube demonstration video for SERS distributed system. When you click this, actually it shows the YouTube channel. I'm gonna go to the channel now. So this is the channel. In the channel we have a you can go, I guess, by typing GDS Engineering R&D simulators and training. So there are a lot of videos here that can be watched. Okay, and then let me pause this. So now let's continue. This is the animation. This shows the animation of the two-stroke engine on the main GUI panel. While doing that, we want to say the speed of the animation is synchronized with the engine RPM. So we reduce the RPM in the engine control room. Now we see that the RPM is decreasing to 60s now almost, and then while it is decreasing, as you see, this animation is synchronized with it, and that decreases too. So that's what we want to say. And this is also the same thing for electronically controlled engine. The previous one was conventional type of engine, because this one doesn't have camshaft and this is electronically controlled engine, we still have the model animated. So it's good to see that something is moving there, you know, and that is synchronized with the ME speed. That's a good thing, I think. So with this, it can be with some animations, the simulator can be enhanced. Now here we demonstrate the ballast water treatment system for ballasting and not deballasting operations. And ballast water treatment system is basically here lined up, and there is a time to wait for the system to be ready, basically. This throws a lot of energy, by the way. And you see that like the pipelines are being highlighted. That helps a lot to see what is working and what's not working. For example, here the system, as the system is lined up, you can see the flow or availability of the flow on pipeline. With that, the student is able to trace the pipelines. Otherwise, it becomes difficult, especially when the pipelines are complex. It's better to be able to see the flows. Okay, the ballast water treatment is actually, we will have a bigger, longer video to only talk about this. So this is just an example. With the like fans working, you get some indication that something is working there. This is important. And one other example is the delivering the CO2 into the engine room. Still, this is showing that this part of the software is enhanced with some animations and additional simulations. For example, here, before actually having the CO2 goes into the engine room, you must, of course, turn off all the pumps, and quick closing valves must be closed remotely from the emergency response station. This is what it is done now. Because of the valves are closed, there is no fuel flow to the main engine, and then now the engine is dying down, and CO2 system now can be operated. This is basically the demonstration of the CO2 system being operated, and there is also big video for this explaining how this is lined up and so on. This is allowing now for people to evacuate while the alarm is going on. You know, the simulator environment has the alarm, different alarm for CO2, different alarm for general alarm, different alarm for fire alarm. So all of these are different gonna be. And one other thing to show is the software is enhanced with the additional animations, and this shows like additional animation is shown here with the timing diagram, so the student can actually visualize how the process is done inside the engine cylinder. We will probably enhance this a lot, you know, show a lot of, we can do a lot, many things about this, valve adjustments, and we can show parameters here while this is moving and so on. So there are a lot of things, and the next version is gonna have when you change the RPM command, the student is going to be able to see the RPM is changing, and this ball basically showing the timing, where it is in the timing diagram is going to be speeding up. And also it's going to be static also, so when the crank angle is selected, turning this in each time like 30 degrees, the student is going to be able to actually stop right there and then understand the parameters right there. So we'll have a lot of tools about that. Now we started doing the 3D walkthrough back in 2014. Then we deferred the development for the following two reasons. First of all, this was not a requirement by STCW 2010, and we have seen that 3D walkthrough may be useful for new or freshman students who are not familiar with the real ship yet. However, in our school, we take students to the training ship environment, and then boom, you know, everything is physically already experienced. So we did not give priority to 3D. Is it a good thing? I think it's a good thing, but there's that increased a lot of development time and also the cost of the simulator. So we said, okay, what is the real purpose here? Real purpose is for engineers to understand the parameters and to understand the components, how it is working, and troubleshoot them. So we started doing some like 3D demonstrations, like the figure shows, like this compressor. There is a button near to it. When it is clicked, it shows the 3D view of the compressor. This feature can be enhanced a lot, which we started doing slowly. Like for valves, we started putting like eye mark, and this should not only show the operation with animations, but also may give some information about it, and maybe like troubleshooting ideas about it. So the many things can be shown there. So we should use the great capabilities of the softwares and computer environments to do such things. And similar one, this is a adjustment valve for but with a solenoidally controlled butterfly valve. So there are several others. This is also butterfly valve with manual operation. This is also view from ship engine room simulator from bearing systems. So the bearings are animated, so these can be all animated, or 3D can be basically integrated into 3D. And our refrigeration plant, we wanted to see everything is working. Basically, with the colors you see, you know, things are the flow types are different with the colors, and also with things are moving, you see something is working there. That's a great thing. So we do the similar things with the boiler system and economizers and so on, and also say similar things for the freshwater generator and separator. Our separator is actually, before it is working, this is not in color, and then when it is working it's in color. And then we will also have we don't have it right now, we will also have the inside section of the view of the separator with a switch, so the student can see what's going on inside with these flows. So we're gonna be animating those. But what we have not shown on the screen is there's an info button here. When this is clicked, actually it shows the timing graph for the separator. So separator is controlled with a timer of with actions. Actions are programmed there. So this is showing how long one action continues and what is next and so on. So there is a graph for that we didn't show in this photo. So there are some components that we're gonna be adding more, and we're gonna be actually opening and closing some control panels. Electricity is big thing. Yeah, we teach a lot of mechanical things to students, but electrical details, we think it's more important, and we need to show those. We are adding those basically. This view is showing like inside of a transformer. This is already in our simulator for high voltage demonstration. And this shows also some simulation, additional simulation for correct connection types. In fact, using the input parameters shown on the screen, on this additional screen, and calculated parameters, students can be assigned with additional exercises. Students maybe need to calculate the output parameters for the given input parameters. This could be a good exercise. And this is also another additional simulation that is already, this capability is already in the simulator. This is showing the simulation of the control of a three-phase motor. The star delta connection is interactively simulated as shown on the screen. These type of now like portional or partially simulated things gives us ability to detail out the section to better understand. So we already have that, and we will have many of these in our simulator. One other thing is that we don't see but need to understand in the engine room is how the air valves work. So this is an example of a distributor. This can be actually enhanced. Like I gave some YouTube video links here. There are many ideas people started having ideas, and we can incorporate them into the simulator, and we will do that. And this presentation is another example. It is showing as an example of a solenoid valve operated manually, and that allows pushing a piston with air. And this is already built in the simulator, and where you see I button allows them to display. Okay, well, in view of the training objectives, the thing is now, I want to talk about this. The training objectives are changing. I mean, actually, it used to be there, but the perception is changing. IMO STCW is already there, and engine simulator, satisfy that already. IMO Model Course 2.07 is there, and there are great examples, and engine simulator should satisfy that already. Now there are new requirements coming. As the new requirements coming to the ships, we want to implement those in our simulator too. And now SERS 2.0 requirements are example. SERS 2.0 document specifically states the use of the engine room simulator for the not student, for the personnel working on board. Onboard personnel must be trained using engine room simulator as per the SERS 2.0 requirements. So, and also what I've seen lately is what we've been doing 20 years ago was a PhD dissertation. Now that became a regular day-to-day business for the inspectors. Now the inspectors working every day, they are dealing with the like energy management and fault tree methods and this and that, all like higher level things. So they need to better understand now about the engine room systems than they did before, to be able to respond to the problems arising by onboard personnel. So we are getting a lot of requests nowadays from the companies for training, and we would like to have our simulator be able to support component level and detailed level subjects, so that it becomes useful also for watchkeeping officer and also chief engineers or second engineer. So if you have the details, this type of details level, there will be some things that they can learn. Otherwise, it's a typical simulator, and they did that already on board ship. They already know everything. You cannot use that software in such training. For example, like how to select the pump. What is the static head, and what is the current friction rates and so on, and why we selected this pump, or what is the energy management considerations for a specific pump. These type of things, if the simulator can support these things with some graphs, that's great, isn't it? This is just an example. There are many examples. This is basically my presentation is about. We will be expanding our capabilities through additional detail level simulations, and also 3DWorks, depending on the user needs and user demands. We will try to respond to those in timely manner, and I thank you very much for listening today. Thank you.